So if you have homework questions, keep it out. That's why I said get 731 out. We can also take questions on 725 if you need, but we already talked about it. But in the ebook, and I know today's lesson 732, but we're going to wrap up something from last week.
Or the ebook.
In the ebook, you want to click on the book, click on chapter 7, go to 7.3.1, and go find problem 87. Not homework help, not Desmos. Now, we're gonna end up in Desmos, but we don't get there through Desmos. We get there through CPM. Desmos just hosts the website because it uses some of the Desmos technology.
Oh yeah, my initials are CPM.
So what you're looking for in the ebook is in 87. It says the 787 student e-tool. That's what you are looking for. But while people are finding that, and then once you find it, you can check your homework. Let's check homework.
712. Oh.
Now I'm scrolling. I think somebody had asked me to go back a couple homeworks and talk. Oh, I was fighting with the smart board is what happened. I remember the last time we were checking homework, I got in a disagreement with the smart board. So that's why it was all the way back at 721. It just jumped back there on its own. So there's a lot of answers will vary or C graph. So you should be able to look at these graphs and tell approximately if you're right or not. If I need to zoom in on anything, you can let me know. But any questions on any of this?
I don't know.
And actually, guys, with this not being due today, this video will be posted probably by the time you get to extensions. You can always check the answers. That's probably OSU calling to make sure that I'm coming tomorrow.
Wait, I have a question on
Maddie, I saw your hand move there. Yeah, you were starting to raise your hand. Then my phone rang. But you got a question?
I just had a question on 725 on the note that you put in. The note that you put in.
you have a password in the room?
Probably. I need to go restock my pencils. That also means that you need to restock your pencils, right?
Like, don't put the origin in the middle
Here,
of the
dude.
paper.
Here, dude. You're lucky I like you. Don't lose this, because it's like my last pencil. So, when you go to graph something on a space, it is beneficial to count the space that we have before we start. So what I mean by this, it may, notice I'm not telling you what you have to do, but it may be easier if you do not put the origin in the middle of this graph, because we're trying to reach -6, 3. And if I put my origin like right here, notice that I would only be able to count out -1, 2, 3, 4, 5, and I wouldn't be able to reach -6. So when we go to think about graphing things, we just want to make sure that we'll be able to reach what we want to reach. So it's probably easiest if we put the origin, or at least the y-axis, like somewhere on the right side of the graph, so that my x's can reach the negatives nice and easier than having to draw extra parts of the graph. So just always look at your extreme points, meaning like the furthest away, and say, okay, if I want to reach -6, I want to leave at least 6 on this side. So the closest that I would want to put the y-axis would be here, but I would probably bump it over to here so we can more easily see what's going on. So if I want axis here, and then my y's, I have a positive y and a negative y. So my y's, I should just really probably kind of balance. So then -6, +3, 1, 2, 3, 4, 5, 6. -6, +3. Guys, make sure you're double checking these points because some of you are still goofing up x, y. And then -3, -1, -3, -1. And then we could draw the slope triangle if we want to figure out the slope of this line. Yeah, I normally use a straight edge. No, there's no need to applaud anything. Any questions? No, and actually, you're bringing up an interesting point. So I was watching a movie this weekend that this teacher talks to his class about, like, now why did you all start clapping with each other? Like, because just one person started clapping and then everybody, like, joined in. And he's discussing, like, the need to feel like you belong to a group is really dangerous, depending on, like, well, if the group think is going a bad direction and you just want to feel like you're part of that group, you can sometimes make poor choices based off just kind of going with the group. Yeah, Jake?
794.
794? That wasn't even from 2.5.
It's on 731. Tonight's homework, the one we're checking. Will you want checking it?
Well, it's not really tonight's homework. It's due tomorrow. But yeah, I mean, I will put it back up. Sorry, thank you for bringing that up. 94, though? Oh, because we went back to 2.5. So 3.1. Guys, 2.5 was due, but a lot of you didn't turn it in, so it's a good thing that we aren't doing the homework contest right now. I can give you a count of how many of you owe me 2.5 as of Friday. It's easier for me to tell you that 7 of you turned it in. 7.2.5 was due on Friday, and only 7 of you turned it in. So if you still have 7.25, and you still need to finish it, well, that's a problem. But it needs turned in as soon as you can. 7.31 is due tomorrow. I mean, I guess we could say 7.25 is due today if you really want to say that. I need to change my board still because I've had 0 downtime today. Everyone who's out that's been emailing me, I've been trying to respond and get them taken care of. But there's a lot of people missing right now. Yeah.
Speaking of the horror contest, you said Friday that we would talk about it today.
Yeah, we need to make like a survey. I've had 0. I should make myself a note. I just need to make like a Schoology survey or some kind of survey so that we can decide what to do.
Do we need cane survey?
We're not getting canes because I cannot afford that.
I'll buy it.
For what it's worth, please do not complain about any of the options of where this is going to go, because all of this is just out of like the kindness of my heart. Worthington did not say host a homework contest and buy food for your kids. I just decided to do that, but like I can only do so much. So like I can do more than getting you each an Oreo, but I can't buy you each canes because I can't afford that. Right? Like, when you're an adult, it's all about, like, what do I spend my money on? Because, sadly, money's a thing, and it matters. So, Gus, you are very much distracting me right now. So, please be gracious and thankful for what I do offer, and if you don't love it, just keep it to yourself. Okay? Like, let's figure out what will make the most people happy, but I'm tired of having people complain, oh, we want canes. Okay, go buy yourself canes. I'm not buying you canes. Get over it. If you want canes or nothing, guess what? You get nothing. Love you. Welcome to life.
Yay.
When people are going the extra mile for you, you got to be gracious. Not, well, I haven't given you anything yet, so I don't know that you need to say thank you yet. But... All right, let's look at problem 87, because technology is one of those things that is really going to help you guys as you head into your future, and it will save you from doing a lot of work on paper. So if you find Ariel's bike ride, and you click on 7-87 Student eTool, it will take you to a Desmos page that has Ariel's data on it. Now, when we get to Desmos this way, or when we get to like a CPM activity this way, Gust is doing a great job showing me exactly why I'm concerned about putting you guys on computer. Gust has zoomed in so far on the words that the only thing he can see is the D on his screen. That is not the point of what we're doing here. Yes, I can scroll and zoom in, and I can keep going. But that is not what we're doing here. So if you can't contain yourself, we just don't need to use the computer. We could do it on paper. Gust. So, we're going to skip on over would a box plot, scatter plot, or histogram be most helpful. We'll circle back to questions like that. But considering that Ariel's trying to predict how long it would take to complete the ride, which is the independent variable, and which is the dependent. So she's trying to predict how long. She's trying to predict how long. Talk to your team about which will we make the independent variable and which will we make the dependent variable, considering what she is trying to predict. Then, based off that, and if you are not paying attention right now, you are not going to know what's going on. Maximilian, you with me? As I see you trying to write something on your paper instead of listening to me. Max, you with me? Yeah or no? Because, yeah, I was about to say, we're still doing stuff on our paper. Then, once you decide which are your X's and which are your Y's, you're going to plug in this data, and when you plug it in here, it will make points for you. So you're not doing anything with this yet. You're going to plug in points. So if you decide that this is X and this is Y, it would be 68, 7. And then that point will show up on your graph, I believe.
Yeah, because it's really far to the...
Aha, there it is. But if I decide that it's 768, then this will be 7, this will be 68. You and your team need to talk to each other about what do you think? Which is going to be X, which is going to be Y, and why. Ha ha ha.
I feel like that's the 18th time we've made that joke.
Oh, it's not going away. Yes. Look, there's only so much time in the day. I still haven't hung back up the poster that fell down.
It's as simplistic as ABC.
There are lots of things I haven't
Easy
done.
as 1, 2, 3, 10. Oh. Oh. Wow. What is this?
That's not what I'm trying to open. Why do I keep trying to open that? All right, I'm a little worried. I'm a little worried because a couple things that I've heard, and it's because I brainwashed you. But I think some of you missed a couple of the words in the brainwashing, right? Like most of it stuck, but a couple words didn't stick to your brain. X is always time is missing a word. X is almost always time. What or you can say time is almost always X, right? You can kind of flip around time and X. Why am I bringing that up in this situation? Any volunteers? Lily? We are trying to predict how long it will take her. And when I'm calculating the length of a bike ride, if I'm trying to determine the time, what we're saying is time is dependent on distance, right? Who knows what Peloton is? Not like a pellet or I guess I need to say a Pelotonia, right? Like the cancer bike ride, right? So every year, like Pelotonia riders, it's this giant fundraiser that we have. How long it will take them is based off which distance they pick, right? There's like a 5-mile ride, a 10-mile ride, like a 50-mile ride, a 100-mile ride. So what we're saying here is that time is the Y value. Time is our Y value here because it's going to depend on the distance we choose. So when I go to set this up, it should be like 768 if time is the Y value. Then it'd be
92.
88. Not 90. Who's misreading this graph? 92. Where did you get that?
That's a fair number.
3.5. Well, too bad it's not the Jake show. 25 and 150.
This graph was broken.
14, 104, 11, 80.
This actually makes it pretty good.
If we zoom out on the graph, there seems to be a relative trend. Now drag your orange points to try to match that trend. So if I drop right here, I've kind of got like 2 points above, 2 points below, and I'm sort of going through 2 of the points. So yeah, you could go ahead and say it needs to be at the origin if you want to make it proportional. It probably would be proportional, right? How long would it take her to go 0 miles? Probably 0.
Does it matter what order you put the dots in?
Not really, as long as you've got your X's with your X's and your Y's with your Y's. So, like, does the order of this table matter? No. I mean, you can tell they're not in order, right? We go from 7 to 17 to 3.5 to 25 to 14. They're not in order. We could put them in order, but it won't change where they are, like, on the graph. Does this make sense how we can use technology to graph points and then just kind of drag a line around until it looks good? Right? This is something that years ago you wouldn't have had. Right? It would have all been place the ruler on there, try to see what looks nicest. But guys, now that you've got technology in pretty much every part of your life, use it to make your life easier. I got a question though. If she has signed up for the 130-mile ride, talk with your team about how long you predict that will take. And you guys might get different answers, but they should all be close to each other. If Ariel signs up for the 130-mile ride, I'm about to ask her volunteer to like tell me how to find this. Like my line right here, I pretty much like where my line is. It doesn't really actually look like it fits proportional. I think it's a little better if I do like this. But I mean, I should probably leave it proportional since this is a proportional situation. So maybe she was just a little faster at first and then she loses her speed, but I'm going to try to kind of match things and put my point like out here. Remember, line of best fit is kind of up to you. Walter, is that a hand up? I can't tell. Lily, you want to talk me through how to figure this out?
So what I did was I went out to 130 first of all.
Out to?
Yeah, like I just scrolled
Out to or up to?
out to scroll out
Like on the X?
on the x-axis, yeah.
But didn't we say that here... Wait.
The 100 or 130?
Well, I think you're right. What did I say?
You said X is
Lily's right. What's this chair doing here? Who put that there? Lily's right. I said 130 miles, which doesn't sound crazy if you're talking about Pelotonia. But guys, these big numbers, those were time. So Lily's right. If I'm talking 130 miles, I got to scroll way out here, which here's the really nice thing about Desmos. Even when you scroll up, notice how it keeps like a shadow of your graph numbers here. So even when I can't see the axis, or I can zoom out to be able to get to 130 miles. And guys, why is this number so high? Because it's minutes, right? The data they gave us was in minutes, not hours. We're talking in minutes.
So it's about 900.
Yeah, so I'm going to do another question so we can see it a little bit more easily here. Because like most of my graph is down here. So Max, what if I said 130 minutes? Can you help me piece my way through that? How could I follow and figure out how many miles I could go in 130 minutes? How do I use a graph to make a prediction like this? And you can always pass.
You follow the line.
What do you mean follow the line? Talk me through it.
The slope.
Well, if I follow the line, I think I'm going this way, but I don't know how that gets me to 130 minutes. What do you mean just keep going?
Just find it.
Just use your brain.
I mean, like, so just like keep clicking until like I find it?
Yeah.
There's an easier way. We're trying to make life easier. I can see it right now because we made time the y-axis. Right? We made time. If now I'm saying 130 minutes, time is the y-axis. Can we see 130 here?
No.
We can if it's on the y-axis. Because we made time the y-axis. So we would find 130, trace over to where it meets our line, and then trace down.
That's what I meant.
Thank you. This, I was just pushing you to say it differently. I knew that was what you meant. I just wanted you to kind of be specific with how you say it. Guys, this works for x or y. It doesn't matter if I give you an x equals or a y equals. If you got the line, find it on your graph, go to your line, find the other number. Right? Find it on your graph. Huh? I can't hear you.
Is the line not completely accurate because it's the line of best fit?
Well, you bring up a really good point. We can get technology to make our line of best fit for us.
Yay.
So if you input a table of data into technology like your calculator or your computer, you can hit a few buttons and it will spit out the equation of the line of best fit. You don't even have to like guess these things. It'll tell you exactly where to put it. So then I wanted to do 88. Yeah, it still wasn't here. I forgot about. So here's the issue. A lot of us will get confused. Now, I made this proportional to try to make finding my slope a little bit better. When I write this out as an equation, guys, if I could pause your Desmos, I would right now. I want your attention up here, please. If we go to write out this equation, we talked last week about we want to write equations in y equals mx plus b form. Find the slope here. Like on your graph, figure out what your slope is. Remember, we're looking for like a couple lattice points.
Will it not be accurate?
My origin could be a lattice point.
You got 2, 3.
You're totally wrong.
I know I am. It's not 2, 3. It's 2.
What?
I mean, I guess if I just go like
It's
here.
It's 1.5. 2. It's 2. 322. 850. It's 2.
Are you doing y over x or x over y? Y over x.
I found 1.5.
There's a trap door here.
Oh.
Colin.
When the distance is 17 miles, the minutes is 80. Yeah, 80.
Well, that's if you used that exact point. I didn't use that exact point. Are you talking about this point?
Yeah, and
So I didn't use that exact point, but you're right.
if you wiggle it down, it just messes everything up.
If you what? What?
So, like, I put the distance, I numerically arranged it by, like how much of it, and then split it enough.
So, give me your eyes up here. Here's what I'm trying to get you to see. If I use my orange line and draw out my slope triangle, it looks like, I don't know, like 6 or 7 compared to 10. Is this 6 or 7? No! It's like 60 something. So if I say that that's like 65 compared to 10, my equation becomes y equals 6.5 times x. But the part that people will mess up, what did we say y is here? Time. So when we go to rewrite this, we would say time, or the minutes, equals 6.5 times the distance, like the miles, right? So it's 6.5, not miles per hour.
Miles per minute.
6.5 miles per minute.
Pretty slow.
Guys, those of you trying to make it all about you and just guess, stop just guessing. Guessing makes you look silly. The label of your slope, unless anybody can tell me this, you all should have a pencil picked up ready to write this down.
On graph paper.
The label of your slope always comes from the y over the x. Your slope was literally y over x. Right? That's what we did. We did change in y over change in x. Your slope is y over x. It should have those labels. So here, it's 6.5. The slope is 6.5. What was minutes per mile? The label of your slope always comes from the y over the x.
So it's 6.5 over miles.
It's 6.5 minutes per mile. If you wanted to create an equivalent ratio, you could multiply the top and bottom by whatever you want. But our slope, and yours might be slightly off, but mine up here, I just went ahead and said it's 6.5. What I'm trying to get you guys to see is the label comes from y over x, because that's where the slope comes from. We got our slope by doing y over x. Let's try this again. I got a different one for you. Go. That's by hand. How much time do we have? I believe 97 is also in the ebook. So if you go click on 7.3.2, yeah, 97 student e-tool. Let's do this again, but open up the 97 student e-tool. So you can close the other one. You can't see what I'm doing. I mean, yup, you're not the one who told me. I realized it on my own.
Oh my god. That's a lot of points. I thought I had points.
Oh, hey, we've seen the Newton's Revenge before.
We have seen the Newton's Revenge before.
Was that told that they had to close down because,
Wait, what?
Because they were going to get their hands chopped off. They were going to get their hands chopped off.
Yeah, they're like some of the above average height kids. Basically, you would either throw up or you would lose your hands. Yeah.
So we collected a bunch of data, right? We are going to work with our team to draw a line, and we're going to use technology because we're making our life easier today. And then we're going to use 2 points from our line to determine the slope and create an equation. Here are all the points, but we still need to do our line of best fit. So if I zoom out so I can see the axes, all of our points are really tightly clustered. So grab your 2 orange points. Forget about your axes for a minute. Try to best, like where you think these are best. How many data points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 data points. So you probably want to try to go like 6 and 6. I got like 6 and 6. Make sure you drag your orange points out far enough that you don't confuse those for points that were like given to us. right? So our orange points don't count. Those are just points on our line. If I try to match this data, it probably about like this. I don't know. You guys should be doing this on your computer, right? Anyone struggling to find this?
Yeah, that's like exactly.
So then, if we zoom out, so we've got a y-intercept here, right? My y-intercept appears to be right about at like 20. Maybe a little under.
Mine's at 30. Mine's at wow. Mine's at 16.
Mine's at like
So it all depends on how you draw this line, right? So one of the biggest questions is going to come down to, did we make this proportional or not? And if we're trying to perfectly match this data, it doesn't seem like it ends up proportional, right? But is a baby going to get on this roller coaster? I doubt it, right? At least if the ride operators are doing their job. So it's okay to have some y-intercept over here, because do we care about this bottom part of the graph? Not really. What we care about is the trend of this line. But in order to use this line to make predictions, I gotta care about the y-intercept a little bit. So here's the deal. First thing we're gonna do is use your trend line to determine the slope by using your change in y and your change in x. I'm gonna remind you guys how to do this. I don't love the numbers that I just generated, but we'll go with it. So look at yours. Change in y compared to change in x, I can draw that slope triangle. So here to here. I change in y 35, 36, 37, like 38. Yours will be different, probably. And my change in x, I heard one of you want to be exact. 55, 56, 57 and a half. So figure out your slope. Oh, if I get real motivated and get it ready for tomorrow, y'all might have a mini mastery tomorrow, just by the way, because I'm gone at OSU for heart stuff. So be ready. There will likely be a mini mastery tomorrow about slope and association and just all the stuff that we've been doing. Yeah.
I'm pretty sure we did do it.
Didn't do what? Just to double check something. Ooh, this is insightful. The answer to your Google is either. The answer to Google is either. Is X or Y dependent? They could both be dependent on the other thing, depending on when we write it in y equals mx plus b form, guys, when we write it like this, y is dependent on x. Because y is determined, like we already know m, right? M is a number. Y gets found when we know x. But if you gotta stop. You too. Like, you're not as bad, but guys, we have teaching to teach, and you guys interrupting us is unhelpful. If you know the y, you can figure out the x. So we can find x when we know y, but how we say this when we write the equation like this is y is dependent on x. However, if you move some things around, you can flip it around. You can change the x and the y because you're starting to get a lot of freedom in math. So if I do that division, change in y, 38.1 divided by 57.5, 0.66, oh, great number. Yeah, check yours. Yours should be somewhere close to this. I just used this change in y over this change in x. It's going to be different based off your lattice points. Because remember, if you click on the orange point, it'll pop up with what it is. If you click on the other orange point, it'll pop up with what it is. So my slope is 0.66 here. Is this my equation that y equals 0.66x? What am I missing? Nevin? The b, the y-intercept, if there is one, which we've been doing a lot of equations that don't have a plus b. So you need to zoom out and go back and check your y-axis. Do I have a y-intercept? If you click it, it should pop up. Like, I know you can't see me right now, but if you click and then slide on your line, you should be able to find pretty close to what it is. So I'm at like 17 and a half.
How do you get to like the oh wait, never mind.
Change in y divided by change in x.
But how can we get to their I can't say the words. How do we get the, like, I know how we get the numbers, like, how can we, like, get it on the,
I just subtracted. I literally, in the last 2 minutes, said if you click on the orange point, it will pop up. If you click on the orange point, it will pop up. Then you subtract. Just do 143 minus 141. I hate touch screens. But yeah, literally, y minus y, x minus x. We talked about this last week. There was y2 minus y1, x2 minus x1. So, this equation's wrong. Until I put my plus, I'm at like 17.5 on my axis. And here's why that is oh so important. Yao Ming walks up, right? And Yao Ming, you probably don't know, but he's one of the tallest NBA basketball players that there has ever been. He could essentially like just reach up and put the ball in the hoop. It was insane. But really tall people, their bodies tend to break down a little bit faster. So I think he started having some health issues and he stopped playing basketball. He might play like every now and then still, but I don't think he's like a pro that plays a lot. If Yao Ming walks up and he says, hey dudes, can I ride this roller coaster? We need to double check which is which variable. So if we double check our table, I'm trying to find it for us because we're almost out of time. X is our height, and Y is our reach. So what we can tell Yao is your reach, your predicted reach, is 0.66 times your height, but then plus a 17.5. So I know I got to get you guys out of here. All we need to do here plug in a height if you know it, and then you can predict, it won't be perfect, but we can predict what his reach would be, right? If you remember when we did this, our reach was from like butt on the seat up, right? We were measuring like our reach up. Yao Ming, Yaoming.
Oh
He
yeah.
was over 7 feet tall.
You know the one of the most tall person in NBA was on the same team as the shortest person in NBA.
I mean, what are the odds?
It was really cool seeing with each other because it's like the 7'6" guy and like a 5'4" dude.
So, guys, I am 6'2". So if you want to envision how tall Yao was, so about that tall.
Wow.
That, yeah, about that tall. Yeah, anything. All right, have a great day. Get out of here. You already have your homework for today and tomorrow. You already know the answer to that.
No.
You hit us in the forehead.
They had he did cast it.
He was literally in his
Probably even worse, honestly. I think most doorways are 7 feet tall. So I think he overlapped with it by like 6 or 7 inches.
I wonder if basically how can bend over and get like be in a